Okay, so I'm just for this video going to go back and forth here between Desmos and IXL to just talk to you about, I guess, a couple of ways that growth in decay can happen where you don't use the E. And that'll give us just a couple more problems on the assessment, which I mentioned would be coming. And right now, we're just going to talk about first half-life. And then also, what if you're just told something doubles so often or triples so often or that sort of thing. So I'm going to work a few problems with you and then add this exact IXL assignment to your practice and then stick a couple extra problems on your quiz. So basically, the deal is that where we had before the initial amount times e to a power, essentially that rate times time business gives the number of times the multiplier happened. So the number of times a thing occurred is the top part. So if something happens every 2 minutes, then if you go for 8 minutes, that thing happened 4 times. If something happens every 8 minutes and you only go 2 minutes, then it's happened a fourth of the time. So we basically just want to take whatever's happening, doubling, tripling, halving, whatever, and then the portion of the number of times it's occurred. So that sounds crazy right now, maybe since I'm not writing anything, but it looks like this. So this one, the first one says, a colony of 10,000 bacteria doubles in size every 220 minutes. What will the population be 440 minutes from now? So you're starting with 10,000. So whatever you're starting with is always going to go here first, 10,000 times, and then the thing you multiply by is whatever you're doing to it to the power of how many times you did it. So in this case it says doubles in size, so we're doubling. So that means we put a 2 there. And then the number of times it happens, it says every 220 minutes it doubles, and we're going 440 minutes ahead. So the question is, if I have 440, how many 220s do I have? And that's what division always answers. If you put 1 over 2, then you're saying if I have 1, how many 2's do I have? Well, I only have half a 2. But in this case, we got this 2, so we go over here and we put in the exponent 2. So this number here is the exponent. So 40,000 is our answer. Okay? Then this one says the half-life of a radioactive kind of strontium, I suppose, is 10 hours. Half-life means the period of time it takes to have it. So they're saying it gets halved every 10 hours. So if you start with 240, so 240 goes here, and instead of doubling, we're halving, so I can put 0.5 there, that's halving it. If you start with 240, how much will be left after 30 hours? So if I have 30 hours, how many 10 hours do I have? So this would become 30 divided by 10, which is 3, and I know some of these you could do in your head, but this is, a habit, I guess. So the answer's 30. It's very encouraging, this IXL. A town doubles its size every 66 years, so this is going to be 2 because we're doubling. If the population is currently 7,500, so 7,500 goes here, what will the population be in 132 years? So in 132 years, how many 66 years do I have? So 132 divided by 66. So that exponent is 2. So the answer is 30,000. Pardon all my tapping, but I'm using a keyboard here. It's kind of wobbly. You have 160 grams of a radioactive kind of protenium something. I don't even remember the number now. That was so weird. Okay, 160 is what we've got. its half-life is 27 days, so we're having, so 0.5, 27 days, how much after 81 days? So if I have 81 days, how many 27 days do I have? I have 3. And then the answer is 20. There's a population of 281,000 bacteria. So 281,000 goes here. If the number of bacteria doubles, so 2, every 292 minutes, what will the population be in 584 minutes? So if I have 584 minutes, how many 292 minutes do I have? Or did I? Oh, I typed that in wrong. 584. So the exponent is 2. So 1,124,000. 1,124,000. 233,000 bacteria. And it's doubling, so my 2's the same. 216 hours to double, 432. So 432 divided by 216, that's still 2, so 932,000. Scientists are modeling the spread of a hypothetical virus. In their computer model, there are currently 490 people infected, and the virus is spreading at a rate of 10% each day. Okay, so what that means is it's an increase of 10%. So you remember if you have an increase of percentage, then it's 1 plus, and then you make that percentage a decimal, so you move the decimal twice. If it's a reduction, then it's 1 minus it, because we have 100% plus another 10%. So altogether, so we've got 490 people, and we've got 110% each day, so 1.10. And that's each day, and this is 15 days, so I don't have to divide. It would be 15 over 1, but 15. So it's people, so we're going to round to the nearest whole, so 2,047. Okay, now we're back to half-life, so this is going to be 0.5 again. And we're starting with 6,880. And the half-life is 44 hours, and we're going 88 hours. So if I have 88, how many 44s do I have? 2 of them, so 1720. Okay, so farmers are fighting a fungal growth that can cause crop failure. 9,160 hectares of farmland. So we're starting with 9,160. The infected area decreases by 15% every year. So that's 100% minus 15% is 85%. So we would do 0.85. But so where this comes from, and you can do it like this too. You can put parentheses right there and do 1 minus 0.15. And then delete this. So you can do that as well. That'll give the same result. If you don't want to, go ahead and subtract it. So if it's an increase, it'll be 1 plus. If it's a decrease, it'll be 1 minus. And then whatever that percentage is, but in decimal form. How much farmland will be in 9 years? So 9, remember this down here would be 9 over 1 because it was given per year. round to the nearest tenth, 2121.6. Okay, there's a population of 568,500. And it doubles. So this is 2. Every 110 minutes, and we're going 440 minutes. So if I have 440 minutes, how many 110 minutes do I have? And we get 9,096,000. Okay, so let's maybe do a couple more here. Average health premiums have been increasing at a rate of 10%. If an average family's premiums are 11,100 this year, 11,100, what will they be in 3 years? So increasing means 1 plus, and then it's a rate of 10, I think it said. So 0.10, yes. And 3 years. So 3 over 1 is what we put down there, so 3. 14, 7, 7, 4, 10. Okay, a robotics company sells robot vacuum cleaners. Since the newest model was introduced a while back, the old model has seen its sales fall and decrease are the same, by a consistent 20% per month. So this part is going to be 1 minus, because it's falling, and it's 20%, so 0.20. Remember, you move the decimal twice, so from the 20 you go 1, 2 over there, so it's next to the 2. If 5,430 old vacuum cleaners were sold this month, so 5,430 were sold this month, how many will be sold 8 months from now? It's like 911, because we can't sell parts of a vacuum cleaner. Okay, so hopefully this is enough to get you guys going on this. And of course, there's always pause and rewind. So anyway, I'll get this posted. I'll give you the link to this, and I'll add a couple of problems to this section.